In section 10.2, we learn to use hypothesis testing to make a decision on whether or not a sample supports or does not support a population mean. We will not be reaching a different result than we get with confidence intervals. The null hypothesis is the supposition that there's no change in a value from some pre-existing historical or expected value. The null hypothesis literally supposes that the change is null, non-existent, that there is no change. The alternate hypothesis, we use the letter H and a subscript 1 for that, is the supposition that there is a change in the value from some pre-existing historical or expected value. Note that the alternate hypothesis does not say the new value is correct, just that whatever the mean might be, it is not given by the null hypothesis. So we run hypothesis tests to determine if data confirms or rejects the null hypothesis. This is similar to what we were doing, essentially the same as our confidence interval tests. I'm going to use the same example as I used in 9.2. 9.2 used sample 1 up here, if you can see at the top of your screen, which had a mean of 5.38. 9.2 came from a data set, seen here in column B, that does have a known population mean of 5.2. And so we're working with this as a known existing value. And we ran a confidence interval for those 5 marbles that were pulled from the population. And we found a mean of 5.38 and a standard deviation and a standard error for that sample, as you can see by the formulas down below. We identified a t-critical, which is the number of standard errors we had to go, and we established an upper and lower bound, and we found that 5.2 was a possible population mean for this sample. That's a confidence interval hypothesis test. We're going to get the same result, but we're going to use the language of formal hypothesis testing. And note that in this course, our results will stay the same as confidence interval tests because we will be working with what are called two-tailed tests. Well, these 10.2, we start off with the same calculations that we did in 9.2. We're going to need to know the sample size. That was 5. We need to know the sample mean. You can see that there. The average from E2 to I2. That's our original sample, still back here, from E2 to I2. And still the standard deviation, we'll need that. And we'll still need the standard error, 0.18, as before. The new part is that we'll be testing against the population mean of 5.2. And so our very first step will be to have a null hypothesis, to know it or to write it or to establish it, however you want to do it. Here I've written it down so we can see it. This is read in the following way, this null hypothesis. The null hypothesis is that the population mean for the sample could be 5.2, that this mean value here, that could be 5.2 for our sample. So this is a little confusing to students because when you first look at this, you say, well, Leland, you told us the population mean is 5.2. We know that. You measured all the marbles. You told us that. Yes, that's true. I measured all the marbles. But we're pretending that I didn't measure all the marbles, that all I've got are 5 marbles, and I want to know whether they support a population mean of 5.2. And that's what this mu refers to. Could the population mean of the sample be 5.2? And the alternate hypothesis, H sub 1, seen here, is that the mean could not be. That's what that does not equal, could not be 5.2. Side note for statisticians, this course sticks with two-tailed tests. And so we would run the two-tailed test first, and then later, if we have some substantive reason to believe it can only be one-tailed, we could go to a one-tailed test. But this course focuses on running two-tailed tests, which are considerably more secure a result than the presumption built into a one-tailed test. So we always have a does not equal in our alternate hypothesis in this introductory course. The alpha we choose is going to be 0.05. Alpha is 1 minus our confidence level. It is our risk of a type 1 error. The textbook, linked below, covers type 1 and type 2 errors briefly in section 10.2, and you should read about them there. But this is simply 1 minus our confidence level. It is our probability of rejecting the null hypothesis when we should not have rejected it. And in this case, our result, we know the actual population mean, so we should not be rejecting. And if we did reject, that's a type 1 error and a false positive. And so we have a risk of a type 1 error of about 5% here. So the two new pieces, that's not actually a new piece, that's just a 1 minus c piece, is not all that new, but slightly new. First, t-critical. Now, we did t-critical before. That's the same t-critical. You will not get a new t-critical in 10.2. The only difference is right here. Instead of 1 minus 0.95, I'm going ahead and putting in alpha, which is 0.05, which is, you take $1, take away 95 cents, you get 0.05. And so that's exactly the same. The other and more complicated new piece is the t-statistic. A lot of t's running around here. This is the t-statistic. Let me calculate this out manually over here. It is equal to the sample mean minus the value we're testing against, the 5.20 value, divided by the standard error. That's why you need the standard error. If you don't have the standard error, you can, of course, do it from the standard deviation and the sample size. But you do need a standard deviation and sample size to make that. And so you could substitute in those into the formula. We get a 0.98. It's these two numbers right here that become the focus of our hypothesis test at this point. The t-critical and the t-statistic. And if the absolute value of the t-statistic is less than t-critical, as it is here, notice I've taken in this formula the ABS, that's to get the absolute value. I only look at the positive value. I could have done and should have done the same here, ABS. ABS ensures that we always get a positive value. We want to look at the positive value of the t-statistic for comparison to t-critical. When the absolute value of the t-statistic is less than t-critical, we fail to reject the null hypothesis. No, the sample mean is not significantly different from the population mean. Yes, the sample could have come from a population with a given population mean. And we happen to know in this special case that that's indeed the correct answer to have achieved. When the absolute value of the t-statistic is more than t-critical, when this number here becomes larger than that number there, and both of those numbers can and do change, we will reject the null hypothesis. We will say, yes, the sample mean is significantly different from the population mean. We will say, no, the sample could not have come from a population with the given population mean. Again, these are covered in the textbook. So our result here would be a result to fail to reject the null hypothesis. There's a double negative in there. That's the way statisticians talk. We didn't prove that the null hypothesis was true. We simply failed to find evidence sufficient to reject the null hypothesis. And so it's a hedge, but it's the way in which we phrase things, because we haven't proven that the null hypothesis is true. We've only got insufficient evidence with which to reject the null hypothesis. It does look like the population mean could be 5.2, but we don't know. In most cases, we don't know what the real population mean is. Well, that should be enough to be able to make a calculation running a hypothesis test against a known value. Again, we are running against a value which we already know. Later we'll deal with what happens when we've got two samples and no value we're running against. As usual, the spreadsheet will be linked below the video, so you can take a look at the calculations that were made. This text that you see here and the text I read earlier are in the textbook, as well as explanations and examples in the textbook. Do see your textbook. This is just to show you some of the mechanics of how to make these calculations. And you can dive into the spreadsheet. Do read the textbook, and as always, do any homework that's assigned for this particular assignment. It will be in Schoology.